Chapter 9, geometric sequences is what we're going over in this video. So find the general term for the following geometric sequence. So what makes this one different from the previous one, geometric and arithmetic? Arithmetic, we had a common difference. So we had our first value and we're adding our common difference to get the second value. We're adding 2 times our common difference for the third value, and we're continuing to do that throughout the entire sequence. But here, we're actually calculating a common ratio. So instead of adding to the previous number to get the next number, we're multiplying. So if we look at these two, so 6 and 3, it looks like we multiplied this one by 2 in order to get 6. So looking at this, 6 times 2 gives us our 12. Looks good. 12 times 2 gives us our 24. 24 times 2 gives us 48, and so on. So here it's a little bit different. We're continuously multiplying in order to get the next value. So just like the previous problem, we also have a formula for the geometric sequence, or the general term for the geometric sequence. That's going to be a sub n is equal to a1, and we're multiplying r to the n minus 1. So simple as that. And let's get a little legend down here. A sub n is still going to be considered our nth term. So that's why we call this a general term. So it gives us generally every single sequence, or every single value of our sequence. Next value we're looking at is a1. A1 is our first term. Next value we're looking at is r. So before we had a common difference, this time we have a common ratio. And last variable we have up here is n. It's just the number of the value, or the term. So term number. So I might have named it something different in the previous video. I don't know off the top of my head, but we could interchange them. N is just whatever number we're working with for that problem. So with that, let's try to find our general term for this geometric sequence. So starting off with the formula, a sub n is equal to a1 times r to the n minus 1. So find the general term. We just start plugging things in. The general term is just going to remain the same. So a sub n is equal to a1 is the first term in our sequence. So we could just replace that with a 3. R, we have to do a little bit of math for this one. So let's look at the second term and divide it by the first term to find that ratio. So 6 divided by 3 is equal to 2. All right, so far 2 is r, or 2 is our common ratio. Let's look at this, 12 and 6. 12 divided by 6 is also 2. Let's jump up here, see if we could find the common ratio there. It should be exactly the same. 96 divided by 48. Looks like that as well as 2. So the common ratio for this problem is going to be 2. N, we're just going to plug n in, so we don't know exactly what n is. This is a general term, so generally, or this generates all of the terms of the sequence. So we're just going to leave n as is. So I want you to take notice that 2 is what we're working with here. 2 is what's being raised to the power of n, or n minus 1. So we cannot combine these two. So again, not combining these two, because if we look at this, 6 to the n minus 1, that's going to give us, or that's going to generate a completely different ratio. It's going to generate a completely different sequence. So this would not be correct. And now that we have that, let's see if we could find what these terms are. So this is the first term, second, third, 4th, 5th, and 6th. So let's find the 6th term, and we should end up with 96. So a sub 6 is equal to, we're grabbing the information that we just found right here, or just created. So 3 times 2 to the 6 minus 1. 3 times 2 to the 6 minus 1. A little bit of order of operations, so we could simplify that. And now simplifying this part here. 2 to the power 5. So 2, 4, 8, 16, 32. 32, and then 32 times 3. Looks like that's 96. So it looks like what we chose here to be our geometric, or I'm sorry, our general term for the geometric series is true, because when we plugged in this, we ended up getting our 6th term here. So there we go. We could just automatically say that this is a general term for this geometric sequence. If you have any questions, please feel free to ask. Otherwise, bye.